Since this is Unit 2, Segment Lines and Angles, Lesson 2.5, Angles and Angle Pairs. Lesson 2.5, Angles and Angle Pairs. You're taking a look at this page. Make sure you get a date, time, and location. This page, I want you to finger track and read it aloud, please, and attempt to complete. Your job is to find everything possible. Pause, and then restart. Welcome back. It says right here that we have a segment with 3 collinear points where point A is the midpoint of CT. Let's draw that. We have CT, the segment, and A, which is the exact midpoint. We should have hatch marks. And C to A is 3x plus 10. A to T is 5x minus 14. Find everything possible. And we see here we have 2 choices. Either we do something plus something equals a bigger something, or something is equal to something. Because we have a midpoint, we're going to go this way right here. So we know that the segment CA equals the distance of the segment AT. Circle, plug, chug. And you solve. We get x equals 12. Now you're not done. This is not algebra class. Life does not end with an x. So we're going to take that value of x and plug it in right here. That's going to be 3 times 12, which is 36 plus 10. That is 46. Let's check this one out. 5 times 12, that's 60 minus 14. That's also going to be 46. Hopefully you didn't overlook this one here all the way down, which is 46 plus 46, 92. All right, we are graduating from segments, and we're going into now angles. As I read, check it off. By the time we're done, we're going to talk about angle measures and what's called angle pairs. You need to be familiar with these words: acute and obtuse, a linear pair, adjacent, complementary, supplementary, vertical. So by the time you're done with this lesson, you need to be familiar with all those terms. You see angles everywhere, all kinds of different ways. So we're going to be talking about how to spot and use angles. That is a particular kind of angle that we're going to be talking about in just a moment. First off, let's define an angle. An angle consists of 2 rays joined at a common point. That point is called a vertex. When I say joined, think hinged. We're going to draw an angle XYZ with a vertex Y, the measurement of 65 degrees. 65 degrees. A vertex is Y. That means it's going to be hinged right here in the middle. And we want it to be 65 degrees. So it doesn't matter which way you go here. We can go this way and measure along that line, or this way. But I'm going to come here along this side. We're going to go to 65. So there's 60, there's 5. Now we're going to draw 2 rays. So we're going to do X2. That's point X. XY one way, and the other way is going to be YZ at the 0 point. So an angle XYZ, angle XYZ, you always trace and sweep. In that order, let's trace and sweep X to Y to Z, trace and sweep. And in this case, its measure is 65 degrees. Y would be the vertex. Now, there's a difference in notation. Just like in segments, there is a difference in notation between EF and EF with a segment above it. There's a difference in notation here. If I want to talk about the physical angle itself, the physical arms of the angle, I would write it like this. Angle, and I write X, Y, Z. Notice you always put the vertex or the hinge in the middle. This represents the thing of the angle. Now, if you put this little m in front of it, that means measure of, measure of. That little m means measure of. And it reads like this. The measure of the angle XYZ would equal 65 degrees. So that little m there means measure. So there is a difference between angle X, Y, Z and measure of the angle X, Y, Z. Measure is the actual number. This is the physical angle. I'll give you a chance. We're going to practice some drawings here. It says draw an angle, EFG, with an interior ray, FV, and an interior point, U, and an exterior point, W. Okay, so we're going to start by drawing an angle EFG. It doesn't specify where the angle is acute or obtuse, so I'm just going to draw. And F is the middle, that makes F the hinge. So we have EFG. With an interior ray. Interior means inside the angle. See that F there? That's the same F. Interior ray, FV. An interior point U. So somewhere inside the mouth of the angle is point U. It doesn't matter where. And an exterior point outside the mouth of the angle would be point W. Okay, I want you to try this. Press pause and complete. Restart when finished. Do not just copy. Pause. All right, it says draw an angle CAT with an interior ray AD. Let's start with that, an angle CAD. No matter which way you face this, left or right. And A must be the hinge here because it's the middle. Doesn't matter where your C started, CAT. It's an interior ray, AD, so it doesn't matter where AD goes. If I don't tell you it's in the exact middle, if I don't use the word bisect, do not put it in the middle. Offset it a bit. AD, want you to trace and sweep CAD. So trace and sweep CAD. Then draw an interior ray of CAD. label it AE. So inside that is another interior ray, A, same point, E, and it's inside CAD. Doesn't matter whether you face that to the right or to the left, but it has to be interior. Now there's 4 types of angles you need to be familiar with. 4 types. First draw. First off is a right angle, of course, a right angle. And if I ask you to draw a right angle, you must put that little box there. That means it's exactly 90 degrees. An acute angle is less than 90, obviously. And just to remind myself that it's a smaller angle, I usually pronounce it acute, like a cute little angle. Versus obtuse, which I pronounce obtuse, like big angle. It's bigger than 90. And then you have your straight angle, which is 180 degrees, and you're probably thinking, that looks shockingly similar to a line. Well, guess what it is? It's a single angle that makes a line. That's called a straight angle. It's named straight for obvious reasons. So let's try this problem together. It says we're going to draw an acute angle RST with an interior ray SO. So I'm going to do that first. An acute angle RST. So let's make an angle less than 90. That's RST. That means S has to be the hinge. Doesn't matter, RST. When we have an interior ray SO. So again, that's the same S. It doesn't say it's in the middle, so we're going to offset it. And that's array SO. Now it says angle RSO is 3 times as large as the measure of angle OST. To be very trace and sweet. RSO. RSO is 3 times as large as the angle OST. Trace and sweep, RST. And the measure of angle RST is 76. Find everything possible. Let's make sure we label here. This bigger angle is 3 times bigger than this, but we don't know it, so that's going to be X. And this is 3X. Now we can do this. We know that the measure of, if you do colors here, I'm going to use colors because it's really easy to see this. The measure of the pink angle plus the measure of the purple angle equals the measure of the orange angle. And the orange angle is bigger, so I draw it slightly bigger. Colors really help here. So now I circle plug chug. Pink angle. Purple angle. Orange angle. So for X. Now don't get all happy when you solve for X because we're not done. We are told that this angle right here is X, so we just found that. That's going to be 19 degrees. Then for the pink angle, we have to do 3 times 19. Which is 57 degrees. And then we can do a check. Here's our check. 57 plus 19 adds up to 76. Yay, aren't you smart? I want you to take this page on your own. Finger track and read. Label, solve, find everything. Okay, let's see how you did here. So we started with the fact that this was a right angle. Hopefully you actually read that out loud, because if you didn't see that, it would have made this really tough. So it's DOG, and O is the hinge. And you have to have a right angle box. Trace and sweep. Trace and sweep. Okay. Take care of that information. The measure of angle, we have an interior ray OT here. So OT, we don't know where it is, so don't put it in the middle unless you're told it's in the middle. And we are told that DOT, the angle DOT is 4x plus 5. And the measure of angle TOG, TOG is 4x plus 13. And then you ask yourself, how do you solve? Well, keep in mind that the whole thing is 90. So you should have had 4x plus 5 plus 4x plus 13 equals 90. And we solve. We collect like terms. And solve. Don't get all happy when we solve for X, because we're going to plug it back in. S is 49 degrees. This is 41 degrees. Check. 41 plus 49. 90 degrees. You got it. Okay, so that's different kind of angles. Now we're going to talk about what are called angle pairs. Angle pairs. These are relationships between pairs of angles. Use colors if you can. Ready? First, we're going to talk about adjacent angles. There's two angles which share a spine. They share a spine. For example, just darken CP. Write the word spine. Therefore, two adjacent angles is any two angles that share the same spine. So, and there's always several examples of this. I'm just giving one. So we have here angle ACP and angle PCZ. It's adjacent, and it's adjacent at CP. And if you look very closely, you can tell things are adjacent because it'll always have two letters in common. That's adjacent. Adjacent means to share a spine. Darken RC. A linear pair. Linear pair. Linear pair. Linear means a line. Pair means two. It's basically two angles that make a line. Or my little jingle is that these two angles which share a spine and make a line. Share a spine, make a line. That's a linear pair. Share a spine, make a line. For example, could you trace, please, FER and now trace RCP. Do it again, physically trace it. FCR, RCP. They share a spine and they make a straight line. These would be considered a linear pair. So once again, that's angle FCR. Share a spine, make a line. They share a spine at RC, and notice it overlaps. So watch carefully, because I'm going to say this twice, and we're going to talk about this more in class. All linear pairs are automatically adjacent. But not all adjacent angles are linear pairs. All linear pairs, by definition, are adjacent, but not all adjacent angles are linear pairs. So the yes and no there. All linear pairs are always going to be adjacent, but not all linear pairs. All adjacent angles are linear pairs. Vertical, by far the most important. Put a little star by that. By far the most important. Vertical angles are two they're the two opposite angles that are created by two straight lines. They're really easy to catch. I call them bow tie angles. Think of a bow tie. I also call them cat whisker angles. There's a little pink cat whisker there. Okay, let me show you what I mean. Ready? Can you trace the line FP? F to P, the line. Just trace it, physically trace it. Now trace the line RZ. RZ, physically trace it. Again, trace over FP, trace over RZ. These angles directly across from each other. Those are called vertical angles. What's nice to know is that all vertical angles are always congruent. Notice the sweep in the hatch. So anytime you have two straight lines, the angles directly across from each other are going to be congruent both ways. Those are called vertical. They're made by straight lines. Complementary and supplementary. Okay, complementary are two angles which add up to 90. Two angles would add up to 90. Very important you understand this. Draw that little baby right angle there. Draw a little baby right angle. Put a circle around it. Put a line through it. It's very important. Complementary does not mean a single right angle. It's two angles which add to 90. Let me give you an example here. I'm going to use pink and purple. ACR, RCF. These add up to 90 degrees. So we would say that angle ACR and angle RCF, that they are to each other complementary. Why? Because they add up to 90. Now they don't have to be touching, because technically, since these are bow tie angles right here, sweep them, hatch them, we could also say that angle ACR, that's the pink angle, and this angle right here, because it's equal, that's PCZ. We could also say that these are complementary together. They do add up to 90. You were to add these, this one added to this one, it would be 90. So complementary does not mean it has to be back to back, but it does mean we have two angles which add up to 90. That's complementary. The way I remember it is if you make your hand like a sign language C, complementary sign language C adds up to 90 degrees. Complementary, associate that C, complementary adds up to 90 degrees. Complementary goes with 90. Not to be confused with supplementary. Supplementary adds up to 180. So any two angles that would add up to 180 would be sufficient. So taking a look here, any two angles, RCF and RCP, that would be supplementary. Wait a minute, Miss Way, that looks like a linear pair. That's true. All linear pairs are automatically supplementary. All linear pairs, two angles that share a spine and make a line, all linear pairs are automatically supplementary, which means they add up to 180. But not all supplementary angles are a linear pair. You could have two angles that are not back to back. So this dark blue and light blue angle, we would call them as a pair supplementary. I'm just going to abbreviate it sup, but they're not a linear pair because they don't share a spine, make a line. It says in the following diagram, sweep the angles A and B. Determine if they're adjacent, a linear pair, supplementary, complementary, vertical, or a combination. Ready? I'll do this first one with you. Sweep them. Trace. Okay, that's two straight lines. That means these are vertical angles. Vertical. And they're not anything else. Try the next one. Trace and sweep A. Trace and sweep B. Now we do know they're adjacent because they're back to back. But they do not add up to 90 and they do not add up to 180, nor are they a linear pair. So they're just adjacent angles. Okay, you're going to go through this entire page, sweep A and B, and determine, again, your choices are, I'm going to write them up here, vertical, adjacent, complementary, supplementary, linear pair, or some sort of combo. Pause. Welcome back. Let's see how you did. Okay, these two, this A and B, they are, one, they're adjacent, they're back to back. Two, they're supplementary, because they add up to 180. Three, they are a linear pair. They share a spine, make a line. So they are all three. 1, 2, 3. Check this one out. We sweep them. Okay, so one, we know they're adjacent because they're sharing a line here. So they are adjacent. Two, they add up to 90 degrees, so it's also complementary. So they're adjacent and they're complementary. This one, share a spine, make a line. So these are a linear pair. But they are also adjacent as they share a spine. And they certainly do add up to 180, so they're also supplementary. Taking a look here, I have two straight lines, and they're right across from each other. These were vertical. Last one. There's A, and there's B. We share a spine, we make a line, so they are a linear pair. They add up to 180. So they're supplementary. And they are adjacent. So I think you're beginning to realize if something is a linear pair, it's automatically these two as well. Last one, A and B. They're definitely adjacent because they share a spine. And that's it. They're not complementary. They're not supplementary, nor are they a linear pair. Okay, your job down below is to use these colors, preferably red, blue, green, purple if you have it. Things that look horizontal and straight up vertical are. These are what are called roof trusses, different kinds of designs for a roof. And your job is to spot these pairs of angles, adjacent and complementary, linear pairs, vertical, and non-complementary adjacent. So I'll do the first one. First one, the easiest ones to spot are vertical, because anytime you have a straight line, they're vertical. Oop, let's keep my color straight. We're supposed to do that in green. So I have vertical angles there. And then if you take a look here, I have linear pairs. Anything that shares fine, make a line. So for example, these two angles here, that one and this one, do you see how they share fine, make a line? Or I could have gone this way. Share a spine, make a line. Adjacent and non-complementary, in this case, would be these two angles, the yellow angles. Notice those yellow angles, they're adjacent. Let's put them in purple, that's what they're supposed to be. And they're non-complementary. Let's try a couple more. Okay, now here is adjacent and complementary. Adjacent meaning next to each other. Complementary means they add up to 90. So that would be adjacent and complementary. A linear pair, share a spine, make a line. That'd be something like these guys up here, the light blue and the dark blue. There's your line. Share a spine, make a line. Could easily have gone this way too. There's a line as well, and those two angles right there would be linear pairs. Here's a set of non-complementary but still adjacent angles right here. Let me highlight those in blue. That's non-complementary but still adjacent angles. A linear pair would be these guys. Share a spine, make a line. I highlight that right there and right there. You share a spine, make a line. So you get the idea. You need to be able to spot these angles quite easily. We're going to be using them a lot this semester and next semester for intents and purposes. So again, the angles that you have to be familiar with are adjacent, supplementary, linear pairs, complementary, and especially vertical. I recommend you go back to this vocab box here and make sure that you can verbally explain and draw a diagram of each of these 6.